Mark Brown. I'm with the Cosmos DB team, and here, welcome to BRK 117. We're going to hear from Toyota and hear them talk about how they built a durable multi-agent AI system at Toyota to help them design and build cars. I think you're going to love it. There's 4 people up here on stage today. I'm just going to be here to introduce folks. We've got Kenji Onishi from Toyota. He's going to talk about our business challenges here. And then Kosuke Miyasaka. Kosuke Miyasaka. I got your name wrong. I'm so sorry. He's from our App Innovation GBB team. He's going to talk about the system architecture that Toyota built and implemented there. We're going to bring Marco Castellana on. He's Vice President for AI here at Microsoft. He's going to talk about some great new stuff that Toyota is using and some new stuff that's coming. And then I'll wrap it up from the Cosmos DB team, tell you about all the new features we've got coming here today. We'll have some time at the end for Q&A. There's a microphone right in the middle of the room. So if you have any questions at the end, please come on up and ask us some questions. So I'd like to hand it over to Kenji. Please come on up. OK. Thank you.
OK. OK, let's start. Thank you very much for inviting me. I would like to express my gratitude to everyone at Microsoft for their great support in building generative AI within our company. Today, I will talk about Toyota Challenge and building the OBEA system. Our company is the process transforming from a company to a mobility company. This is an introduction to our company. For more details, please visit our website. We have 70,000 employees. We are considering the application of the generative AI in our large manufacturing company. Next, what's the powertrain? In our company, the 3 elements that make a car run are defined powertrain, chassis, and body. Among these, I belong to the powertrain development department. Let me introduce myself. My name is Kenji Onishi. I have been working at Toyota Motor Corporation since 2006. Initially, I was assigned in the development of hybrid vehicle control system. And since 2014, I have shifted to the task of the building development environment. I'm considering how to apply generative AI in our works. Next. OK. First, take a look at this. This is Toyota OBEA multi-agent system we have developed.
Various experts are involved in car development. Toyota's strength lies in having a large number of specialists. On the other hand, because there are so many experts, we have to listen to many opinions when progressing with a single task. For example, creating a car that performs well can lead to worse fuel efficiency and increased noise. To balance these factors, discussions are held among the experts. We have developed an AI system that simulates discussions among experts in a virtual environment, allowing anyone to engage in development while conversing with many specialists. Now, let's take a look at the new way of working that this system offers. We call it OBEA system, Toyota Multi-Agent AI System. This system can automatically summon various expert AI agents based on the content of the questions. There is a lineup of AI agents that can be summoned. You can use the automatic AI agent selection. Let's check what the customers are dissatisfied with.
I want to know about the dissatisfaction of customers with our cars.
This AI registers customer feedback.
I will ask the AI.
The engine is noisy when the accelerator is stepped on.
I want to get rid of the engine noise when the accelerator is stepped on. What is the factor in the voice of the customer?
There may be a muffled engine noise in the low RPM range.
There are many examples. Among them, the muffled sound of the engine seems to be applicable. Which agents would be suitable to address muffled engine sounds?
You can get recommendations on which agents to choose. They are the recommended based on the user's message.
I have identified the agent to confirm with, so I will ask the question.
Resonance at certain rotational speeds can cause droning noise. Motor assist might help.
Okay, it seems like motor assist could be effective. What should be considered when enhancing motor assist?
Manage the temperature of the battery under high load.
I agree, we should pay attention to the battery. I agree, we need to manage the battery condition. What should we do to assess the battery condition management?
Monitor the battery temperature. Implement a system for cooling and heating.
I see, these evaluations are indeed necessary. Path to solutions identified. Using the information we've gathered, let's develop excellent cars.
Thank you. Okay. Okay. I will explain the reasons why we are decided to develop a system. 50%, a number which suddenly appears. This number represents the man-hour required for investigation before carrying out tasks within the company. Investigation refers to activities such as reviewing past documents and conducting interviews with the knowledge individuals. These tasks began with searching for people and gathering documents. In Powertrain, initially, a car only had engine and transmission, but they have now become hybrid, and autonomous driving as added. Furthermore, the transformation into a mobility company is advancing. The amount of research work has been expanding year by year, and currently the workload has become so large that it is placing significant burden on the engineers. The problem our company is facing, while we have good information, it is difficult to find because we are a large organization. The veteran each field holds a lot of information within a company. And consider creating an AI that can replace veterans by developing a specialized RAG for each field. This is referred to as the general purpose RAG environment. and we, we are processing building it. Since the knowledge of the veteran in their heads, we are creating the system to extract that knowledge. First, we will register the knowledge held by veteran as documentation. The AI we build provide answers on the registered knowledge. The veteran can review the answer given by the AI and make a correction if necessary. So, model answer correction. By accumulating high-quality data, it will develop into a useful AI. This AI will become one of the expert AIs in multi-agent AI systems. We are widely introduced this system within the company. By doing so, our fellows are engaging in activities to create their own veteran AI. We have created about 30 environments. As the veteran AIs have increased in this way, I suddenly recall the following scenarios from our regular development work. These are open statements from the high up like this. We want to develop something called new system. Let's bring together experts and do it all once. As a result, a process is created of one floor in our company, where experts gather to carry out these tasks. In Toyota, we call OBEA activity. And OBEA means large meeting room. By doing this, the experts are close to each other, so the work can be very quickly. However, this method is powerful. It cannot always be in placement. Naturally, it is difficult to gather experts all the time. We thought, if we are expert AIs, could you connect those AIs to make this work easier to accomplish? So we created a system that allows us collect veterans' knowledge at any time. We have started considering OBEA systems. This is a system kind of system I envision. The engineer will pose question to the AI, saying, I want to develop something like this. The AI calls upon another AI that seems capable of answering the question. The response from each AI will be aggregated and returned to the engineer. With this OBEA system, we achieve the better development. We are considering trial as 800 powertrain developers. We have received comments through the survey indicating that the development process has become faster. Okay, transformation into a mobility company requires enhancing the development efficiency of everyone, improves in the development process. I believe that utilizing generative AI, we can handle a vast amount of past knowledge and maximize development efficiency. Together, generative AI and engineer will work hand in hand, advance towards becoming a mobility company. This concludes the demonstration and overview of the system. Mr. Miyasaka from Microsoft will explain this system's structures. Mr. Miyasaka, please go ahead with your explanation.
Well, thank you, Onishi-san. And my name is Kosuke Miyasaka. I'm Azure App Innovation Specialist from Microsoft Japan. And I'm leading the support for Toyota project. Before diving into the detailed system architecture, let me first introduce the approach we took in this project. This project was divided into 3 major phases. In initial first phase, we build the RAG, and second, we incorporate image data with the RAG, and finally, we develop the multi-agent configurations. In each phase, we collaborated closely with Toyota, applying the latest technology as it became available. In each phase, for instance, we implemented GPT-4 as soon as it was generally available in the initial RAG phase. And for image integration, we developed GPT-4 Turbo with Vision the day after its release. This rapid adoption of new technology has been essential in accelerating the development of multi-agent configuration. How was this possible? Toyota's application development environment, including the path landing zone tailored for generative AI, allowing us to instantly integrate new generative AI features and path update into our applications. This responsiveness is a crucial factor when building applications in generative AI, given the frequent model update. Now, let's take a close look at the specific system architecture we have developed. Since the GA of Azure Open Services, various retrieval-augmented generation patterns have emerged, enabling our customers to experiment with multiple approach for building generative AI applications. Toyota's too. Toyota has been evaluating different RAG patterns to implementing agent-based solutions. In Toyota's multi-agent system, it's crucial to tailor the implementation patterns to fit specific agent requirement and data characteristics. This slide presents a simplified overview of the RAG patterns Toyota is currently exploring. Among them, Toyota is actively validating 4 distinct patterns. The first pattern connects AI search with SharePoint in straightforward RAG configuration. This setup was selected as a fundamental RAG architecture, given that much of Toyota design data is already stored in SharePoint. The second pattern uses the AOA extensions Azure Functions for a simple serverless RAG configuration. This approach proved effective for quickly deploying serverless RAG system. Both architectures offered easy development. The third pattern leverages Cosmos DB vector search, designed it to utilize Toyota's text-based design knowledge data within a RAG structure. This approach offered high performance and advantage of automatic scaling, even as the knowledge database grows. The fourth pattern implements agents using the function flex consumption plan, providing an effective solution for cost optimization as the number of agents scales. These 2 architectures are prioritized in the case where reliability and performance are crucial. Finally, the fifth pattern integrates the DiskNN features in Cosmos DB for agent implementation. Although this hasn't been yet deployed in Toyota's multi-agent system, it is variable as data volumes grow, requiring high performance and configurations. Given the vast scale of Toyota's design data, the ability to toggle between standard vector search to DiskNN as needed is immensely beneficial. These are the core agent configurations within Toyota's OVR system. Next, let's dive into the how we're implementing these configurations in multi-agent framework. There are multiple ways to configure a multi-agent system, but Toyota focused on capability of Azure Durable Functions. The multi-agent system includes 4 distinct agents focused on batteries, motors, regulations, and system control. The prompts for each agent are defined, and these prompts play a crucial role when the multi-agent system compiles its response. There are 3 main reasons for choosing durable functions. First, it enables parallel processing across agents, enhancing performance. Second, it supports complex workflow, including error handling and retrace. The third, it allows easy monitoring by storing the state externally, making it simpler to review. In terms of implementation, the fan-in, fan-out feature of Azure Durable Functions is used. Durable functions are triggered by a user request, activating 4 agents, which are implemented as functions and launched in parallel with fan-out. Once all parallel processes are complete, fan-in collects the result, which are then compiled by generative AI to form the response. Each of 4 agents has its own unique architecture. To improve response accuracy, we improved the RAG architecture and prompt for each agent. Additionally, by storing conversation log in Cosmos DB, the system can consider previous session data when generating responses for the next session. The main advantage of implementation is that agent can be easily added. Since the agent operates asynchronously and in parallel, adding more agent has no negative impact on response time. This implementation has demonstrated high effectiveness in generative multi-agent responses. This is the overall architecture of this system. As mentioned earlier, this application is deployed in Toyota's secure generative AI native environment. Each question and answer handled by multi-agent system is logged in Cosmos DB, allowing us to monitor for any inappropriate content. Now, let me explain the 2 key layers, the OBS system layers and agent API layers. The agent API layers follows a microservice architecture, making it easy to reuse the deployed agent APIs. For example, as shown at the top of the slide, apps, a single application can easily utilize a specific agent as needed. In practice, we are creating a plugin for Toyota's design application to call a battery agent, which is actively in use. Additionally, leveraging the microservice architecture enables us easily add new APIs and agents. Each agent can be modified to meet specific requirements. Moreover, by using durable functions, we can process tasks in parallel and minimizing any performance impact. We refer to this architecture as the OBS system. It's already in use and delivering significant benefits for Toyota. And we are looking forward to further development with using Azure latest update. So finally, at this Ignite event, we have seen exciting updates for Cosmos DB and Azure Open Services. Notably, Cosmos DB's DiskNN and Azure Open Services, Azure AI agent functions seems especially applicable to our multi-agent system. Leveraging these capabilities, we plan to advance our collaborate work with Toyota to create pioneer use case for manufacturing industries. Now, I'd like to invite the product team to introduce these new updates. First, let's hear from Marco, Azure AI team. Welcome, Marco.
All right. Thank you.
Thank you.
All right. Well, hello, everybody. I'm Marco Castellana. I am VP Products of Azure AI and AI Futurist. And I'm going to kind of roll it back a little bit because we've been talking about these agents, the agents that Toyota has built and has been using. What is an agent, actually? I mean, really, fundamentally, what is it? An agent is a framework that sits above one or more models that allows you to do complex and long-running operations and can take actions on your behalf. And how do these agents even work? Well, they really provide reasoning. That is the key. That's the difference between what an agent is and what came before it, like robotic process automation or search or any of those kinds of things. Agents can do reasoning. And it can do those reasonings to help you search for information, as Toyota is doing, or it can help you take actions. Now, for those of you who missed my session yesterday, which was BRK 102, you should probably check that out on YouTube, because one of the things that I did there, and what we will do again tomorrow, by the way, in Theater C at 1 p.m., so we have another agent session in the big conference area, we are making these agents take actions. And really what differentiates the Azure AI Agent Service from just about all these other agent frameworks out there, because there are a million agent frameworks that exist today. But the differentiator is the integrations, the ability to integrate to sources of knowledge, as Toyota did, but also to actions. In this picture, this is one of the things that I did do yesterday in my session, where I connected it to Outlook, and I made it make bookings in my Outlook calendar. So it's not just about looking stuff up, it's also about taking actions. And there are all kinds of actions that I could make it take. I could make it do stuff in Dynamics. Here I have a picture of where I'm making it do something in SAP or in Salesforce, in all kinds of third-party systems. You can make these agents take action. That is where the rubber meets the road. And now Satya talks about, in the keynote he was talking about autonomous agents. What do we mean by autonomous agents? What is an autonomous agent? Well, now you think of AI as being kind of a chatbot nowadays. You know, everybody thinks of ChatGPT, you type to it and it types to you. But an autonomous agent is really an agent that is triggered by some event in a system. And that event could be a business event in Dynamics. It could be that a record gets added to Salesforce, or something gets changed in SAP, or an email comes in. There's all kinds of ways that you can trigger these agents. So when you think about agents now, think past the chatbot and think about how you might trigger these things to wake the agent up to do something useful. Now, for somebody like Toyota, there are a number of steps that they have to go through to bring these agents to production. Well, the first part of it is evaluation. I mean, think about even some of the things that they just showed. Imagine how much rigor they had to go through to evaluate that the results that these agents were giving to their users were correct. So evaluation is very key, and we have here at Ignite announced some new features for evaluation specifically. There is scalability. So you have to, at some point, when the agent moves beyond the prototype point, you want to get that to all of your users. So you have to scale that out. And then you want to monitor it in real time as agents use it. Now, AI systems involve a different type of monitoring than traditional applications. For traditional applications, you're monitoring latency and uptime. You're looking for 500 server errors and things like that. But with an AI application, well, you still monitor for all those things also, but you're also monitoring for things like groundedness. Is it speaking the truth? Is it telling things correctly? Is it working correctly and taking the right actions? You want to be able to evaluate that in bulk, as I said earlier, but also monitor for that in real time. And finally, there is security. You want to make sure that your agents don't give access to information that the user should not have access to, that the agents don't take actions that the user should not be able to take. These agents should be acting on behalf of the users and should have those same permissions. And so for all of these reasons, we have introduced the Azure AI Agent Service. This is part of the Azure AI Foundry that you've heard about here at Microsoft. And it supports that kind of evaluation, scaling of the agents, monitoring, and security. And as I said, this is just one part of the Azure AI Foundry, which is a holistic AI solution that we announced here at Ignite. But what you heard the folks from Toyota say is that these agents need to be grounded in knowledge. And in many cases, they need to keep memory. They need to kind of remember what it is that you've interacted with them about in the past. And one of the best ways to do that is with Cosmos DB, which is indeed what Toyota is using. And so now, to talk a little bit about how this works in Cosmos DB, I'd like to welcome to the stage Mark Brown.
Right. Hey, that's a great intro. Thank you, Marco. So you heard a little bit about how Toyota is using Cosmos DB today to build this multi-agent AI system. Let me talk about some of the features they're using here today. And I also want to share some of the features they're going to be implementing here in the future. For Cosmos DB, we make the world's most scalable, performant, cost-effective, and flexible database for building AI applications. There's two flavors for Cosmos DB for building generative AI applications today. We have our Cosmos DB for MongoDB, which provides high compatibility for MongoDB Atlas in a fully managed first-party database with providing native vector search capabilities as well. And then, of course, there's our Azure Cosmos DB for NoSQL. So this is for customers that need that infinite scalability or high availability, extreme low latency for their types of applications, which is perfect when you're building these kind of high-volume multi-agent systems here. Instant autoscale, automatic data partitioning, all these features can help allow you to focus on building your multi-agent systems or your generative AI applications rather than focusing on your database. And then, of course, it's built using Microsoft's Disk ANN, which we announced GA here today this week. Disk ANN is Microsoft's vector indexing and search algorithm developed by Microsoft Research. It combines a lightweight, in-memory vector store with full-fidelity vector graphs stored on disk. Disk ANN constantly maintains the index built within the database there. So it's able to withstand very high data mutation rates while maintaining very high accuracy for your applications. Disk ANN's design is uniquely suited for Cosmos DB with the graph stored on disk on very fast SSD storage on cluster for the compute. And combined with Cosmos DB's unlimited scale and best-in-class latency, customers can get the absolute best performance when building their generative AI applications using Cosmos DB as their vector database today. So unlimited scalability is great when you're going into production, but Cosmos is also really, really cost efficient. Customers can use our serverless and get upwards of 1 million point reads for 25 US cents. Now that translates into hundreds of thousands of vector queries as well for their applications. And since it's a pay-as-you-go model, it's really great for starting your new generative AI applications. Also, it's fully managed. Developers can focus on building the logic for their applications rather than having to manage and provision their databases in there. And as a NoSQL database, it's also uniquely suited for applications that are going to go through rapid evolution and development as they go from development into testing and into production. So with all of these great new capabilities for Cosmos DB and its vector capabilities for building generative AI applications, it really unlocks a whole slew of different scenarios for building these types of applications. When you combine the vector data from the database with the operational data, it drastically simplifies the design of your applications. You don't have to ETL it into a single-purpose vector database for your applications. This provides greater consistency for your applications when you have high transaction volumes for your data. Anything committed in there is immediately available for vector search within the database. This makes building RAG pattern applications much, much simpler, way less complex, and more cost efficient. And also enables other features as well, building things like a semantic cache, which I'll show you a little bit later. It's also ideally suited for just capturing chat. Customers were using Cosmos DB to build chat applications way before generative AI or any of these RAG pattern applications. It's even more suited for it now. And then finally, the performance for Cosmos DB makes it ideally suited, and you saw here with Toyota, for handling all of the logging that's going on with the multi-agents within their system there, because it can handle the massive transaction volumes that are going to go through these autonomous agents within their system. Just to put a point on how scalable Cosmos DB is, OpenAI's ChatGPT runs that entire service using Cosmos DB to store all of their data. So every prompt and every completion that you have created using ChatGPT is stored within Cosmos DB. Using a single Cosmos DB database that they provisioned when they started the service allowed it to grow to over 180 million daily active users. And it's fully managed. They've never touched it since they provisioned this thing. They love it so much now, they run over 40 different workloads using Cosmos DB as the backing store for all of these different services. Now, I want to highlight even further I want to highlight even further the power that Cosmos DB brings when you're building these types of applications. So I talked a little bit about a semantic cache. And here you have, in say, simple ChatGPT scenarios, generating responses generally happens pretty fast. It doesn't take a lot of tokens in there. However, when you're building RAG pattern applications, you're now grounding that model with a bunch of data that's going to come out of a database. And this can consume a lot of tokens. And as you may have noticed, generating the responses can take quite a bit of more time. When you're building something like a semantic cache using Cosmos DB, you can make these very, very much faster. And in fact, it can save a lot of money on tokens because you don't have to go and generate a response. Instead of sending all of the context window and the RAG pattern data to the LLM to go generate a response, you can just send the context window into a query in your cache collection and then get all of that back right away. It, in fact, just short circuits the whole pipeline in generating responses. And the results of this are absolutely staggering. In fact, let me show you a little demo here on just how much performance improvement you can get out of here. So I've got a very simple little chat application here, and this is for a retail bike store. And as you can guess, for customer-facing applications, customers tend to ask kind of the same questions over and over and over again, right? So you can imagine if you're a retail bike store, one of the questions you may get is, what bikes do you have? Did I type that right? Now, this is going to take a few seconds to generate here, because it's going to go and do the RAG pattern query, and then it's going to send it to the LLM. And here you can see, let's see, let me move this up here. I'm going to try and see if I can zoom in here. You can see this took almost 1,300 tokens just to process the payload that got sent into it, and of course another 300 to generate the response. But it took over 6 seconds for that whole thing to go round trip in there. Now, let me show you what happens when you cache that. So I'm going to go and I'm going to select another user here in our database. And then I'm going to ask something that's semantically similar, but not the same thing, right? This is a semantic cache. Do you have any bikes? And there you can see that came back immediately. And even more importantly, it took 0 tokens to generate or process that payload because it never saw it, and 0 tokens to generate the response. More importantly, that came back in 145 milliseconds, right? It was almost instantaneous. So this is the kind of power you can get when you're implementing something like a semantic cache for applications, for these customer-facing applications where you have customers that are asking very, very frequent, often the same question over and over again. So this power to create a semantic cache is now possible in your production applications. And we're announcing the general availability for both vector search and DiskANN for Azure Cosmos DB for NoSQL. With this GA release for these features, customers can now get better performance, both for the ingestion of the data and indexing of data, as well as for the searches and the queries within there. Increased compatibility for enterprise features like customer-managed keys, backup, encryption. Also with Fabric mirroring, another key innovation where you can take and connect and automatically ETL your data out of your GenAI applications, let's say your chat app, and then do analytics over all of that. It's a great way, an easy way to help build something like, I don't know, analytics over what your customers are asking you. Customers can also take and now modify the vector policy and also the container indexing policy within there, and then tune that for better performance in there to help increase or improve the latency of their applications. We're also thrilled to announce the public preview for 2 new features. Customers can now perform full text search, giving them advanced text capabilities, and also enhanced search relevance with BM25. We're also announcing the preview for hybrid search. So this is the ability to be able to do both a vector search combined with full text search, and then rank those for even better relevancy for your applications there. So to get more details, I want to direct you to, there's a session later this afternoon, BRK 193. And if you want to go see both of these features and even DiskANN, you can watch it and just see how fast this thing can rip through like 1 billion vectors using DiskANN in there. And then we'll also show detailed demos on using the full text search as well as the hybrid search within there as well. Lastly, I want to point out customers that are looking to explore these new full text advanced features we've built a solution accelerator to do document ingestion and processing in here. So this will drastically simplify getting data from, say, blob storage into Cosmos DB, and it handles all of the steps you would expect. So it handles all the ingestion, all the chunking, vectorization, and then load that data into your Cosmos DB containers. Yeah, go ahead and take a picture of this. The source code for the solution accelerator is up on GitHub here, so you can take a look at that, aka MS link there today. We would also love to get your feedback on this and tell us if you like it, any features, other things that are in there as well. So that is it for our session. Please take a picture of this and then open the little browser and then give us a 5, I think is what we want. I'm just kidding. Please do fill out a survey. I'm going to leave this slide up. Please also take a picture of this. We've got blog posts, announcements, more information, and then also we've got sessions you should absolutely go and hit. Last thing I want to plug here is for any Azure Cosmos DB customers that are here with us today, we would invite you to go and give us a product review with PeerSpot. I believe there's some PeerSpot people outside the room here, as well as back in the expo hall at our booth. And you can get a $50 Amazon gift card as well. So come and visit us outside here or in the expert booth today and leave us. Also, some extra special swag I want to point out. We have the coolest swag, by the way. Coolest database, coolest swag. So that's it. I'm going to invite up our other speakers here for the session. There's a microphone in the middle of the room. And we've got 4 minutes, 23 seconds for your sessions. So thank you very much. Hi.